Hi, I'm Professor Goins and welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in college mathematics, you're in the right spot, so go ahead and click the subscribe button. That said, let's get into the current video. What I want to talk about is how to compute a limit, and I imagine that the people that would watch this would be somebody who's in Calc 1, possibly a pre-calc class, but generally speaking in Calc 1 near the very beginning of the course where you first learn the word limit. You first hear about a limit. And so what I want to do is let me illustrate with an example the concept behind a limit first, and then we'll talk about how to compute those. Let's look at the following function. F of x is equal to x squared minus 1 over x minus 1. Okay? Now, this function, that expression can be reduced, right? The numerator is the difference of perfect squares, so x plus 1, x minus 1 over x minus 1, and of course the x minus 1's cancel, reducing to x plus 1. Now the thing to keep in mind is that even though this function expression and this function expression do represent the same function, they have to have the same domain. So if there's any restrictions up here, we have to carry that along down here. And of course, the restriction is I cannot use 1 in this expression. Therefore, if this represents the same function, I also have to carry along x cannot be 1. So let's go ahead and sketch the graph of what that looks like, right? Thinking about what's the graph of this look like, it looks kind of complicated. It's a quadratic over a linear, but once I reduce it, it's really not that big of a deal. It's just this line with x equal to 1 removed from the graph. So if I go ahead and just do a quick sketch of this, okay, y-intercept is 1, slope is 1, so the graph looks like that. Remember I said x equal to 1 must be excluded, so that means above, when x is 1, I have to go up to that point in the graph and I have to punch a hole in it. Okay. So therefore, this function expression represents the same graph. Okay, now, if you know about what a one-sided limit is, when I approach x from the left-hand side, the function values approach 2. When I approach x equal to 1 from the right-hand side, once again, the function values approach 2. 2, of course, is the y value of the hole in the graph. Now, when you learn about the concept of a limit, the limit of f of x as x approaches a is the common value of the left-hand limit and right-hand limit, of course, when these values are the same. And the way we write that, of course, is the limit of that function minus as x approaches 1 is equal to 2. Now, the way we were able to come up with that is by graphing the function. Now, if this was, slightly altered, like x cubed minus 1 over x minus 1, or something x to the 7th minus 1 over x minus 1, or so on and so forth, right? This could be so many other things that we might not be able to practically graph it and then eyeball what the limit is. So we, of course, want to be able to compute limits using algebra. And that's the primary way that we will do that. And this simplifying steps right here illustrate how we do that. Notice with this expression right here, limit as x approaches 1 of this function, I can't plug 1 into that expression, right? Well, let's kind of look over here at these expressions that are related to this. If I take x squared minus 1, which x squared minus 1 over x minus 1, that's what I have on top. I can't plug 1 into this. So what I did is I manipulated it. I factored the top. I still can't plug it in. After I cancel the x minus 1, I get down to x plus 1. And yes, I do have the restriction here, x can't be 1, but let's ignore that for the moment. If I plug 1 into this, notice I get 2, right? So that gives me an indication as to how I'm going to compute limit values. I will simplify the expression, hoping that I can plug this number in, and then if I can plug it in, I do that, and then I get my limit value. Let's go ahead and look at another example using algebraic manipulations in order to compute the limit value. So let's say I wanted to compute the limit as x approaches, let's say, 4 of the square root of x minus 2 over x minus 4. So this would be a shifted square root function divided by a linear function if I was to graph it. So it's a little more complicated than this guy over here, which is reduced to a linear function with a hole in it. So therefore, I'm not going to solve this or compute this by graphing it. What I'm going to do is use an algebraic manipulation. Well, I can't plug 4 into that, right? So what I'm going to do is I'm going to do something in order to eventually be able to plug 4 into that. Well, if I want to reduce this, simplify it, manipulate it, do something with it, there's a variety of options. One thing I could do is I could multiply by the conjugate. So once you see square roots or absolute values or cube roots, other types of roots, those types of things, conjugate is what you want to use. And the conjugate of this expression is root x plus 2 over root x plus 2. Of course, the ratio, that value is 1, so I'm not changing the value of the expression. I'm just multiplying it by a special form of 1. Now what I'm going to do is let's FOIL the top. All right? Let's use the FOIL technique on the top. So this gives me the limit x approaches 4. FOIL that, root x times root x would be the square of root x. Let's just write it all out. Would be the square of root x plus 2 root x minus 2 root x minus 4 all over. And I'm not going to FOIL the bottom. Let me explain why here in a second. Let me just copy it down here. Here's why I'm not going to FOIL the bottom. So spoiler alert here. I can't plug in 4 because I'm dividing by x minus 4. Right? That's the problem part of this expression. I wish it was gone, right? I wish it wasn't there. So this manipulation, surprise, surprise, is going to eliminate that factor of x minus 4. Okay? So the problem part of this is actually going to be eliminated. And if I was to FOIL that through, I wouldn't have x minus 4 as a factor on the bottom, which is also going to be on the top, in order to cancel. So I then have to do more work to discover how that would cancel. So let's go ahead and simplify that over to the side here. All right. Now, 2 root x minus 2 root x. Those are the same term, opposite signs, so they cancel. Square of a square root leaves the radicand, which is just x. Therefore, what I have at this point is the limit as x approaches 4 of x minus 4 over x minus 4 times the square root of x plus 2. Okay. Remember I said that x minus 4 was going to go away, so therefore at this point it does go away. That's a factor and that's a factor. Common factors are eliminated, and what I'm left with is the limit as x approaches 4 of 1 over root x plus 2. Now, let's trace back through this. At the very beginning, remember those conjugate terms weren't there. I had just this expression here that I couldn't plug 4 into, so I did stuff, right? Use the technical terminology there, stuff. I did stuff to it. I multiply by the conjugate top and bottom, FOIL the top, left the bottom alone, blah, 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 simplified stuff. And then I boil down to an expression where I can plug 4 into that. So I plug 4 into that. So root 4 is 2, 2 plus 2 is 4, so therefore the final answer is 1/4. Okay? The idea is that for a limit value, if I can't plug the number in at the beginning, then I have to do some sort of algebraic manipulation. Now, just in isolation, if I can't plug the number in, there's no guarantee that the limit exists, but chances are if it's in a Calc 1 class, if it's a textbook exercise on an exam, classroom, whiteboard, whatever the case may be, you're going to be able to evaluate it, and you just have to figure out what is the appropriate manipulation in order to compute the limits. Whether you have to do factoring or conjugates or take a bunch of different fraction expressions and combine them on down into one fraction, whatever the case may be. Anyway, thank you for watching, and please consider subscribing.